exercise substitution. So I have two equations, and I mentioned yesterday that when we have two different variables, we need two different equations. So here we have our two equations. Oh, my pen is not working. Oh, here we are. Okay, so we have two different variables. So I need two different equations, and this is what we call a system. Since I have two different variables, I know I will have two answers, one for x and one for y. When I have an equation, my two equations have y equals, I have y equals and y equals. I could just take them and set them equal to each other. What's going on with my computer? Sorry. So I know that this value here, y equals 2x plus 3, if that is a value for y, I could replace that with my second equation. Another ways I think of it as if they both equal y, I could just simply set them equal to each other. So I'm going to take 2x plus 3 equals 5x plus 9. So now I've just replaced one equation with just x's. And now that I could solve using, I'm going to subtract 2x from both sides. Just a reminder, here is that's from here because that replaced the y. And this one here, is this one here. So when they both equal y, I could just set them equal to each other and replace that y with nothing but x's. And that's what I was doing. And this goes away, and I'm left with 3 equals 3x plus 9. And I'm going to subtract, not the 3x, subtract 9 from both sides. And I get 3x is equal to negative 6. Then I'm going to divide by 3, and x equals negative 2. So I have my x answer, but I need two answers. I need my x and my y. So now I'm going to take one of the equations. It doesn't matter, but I'm going to take my favorite equation and substitute my x answer. So here's my x, and I'm going to pick the top one. Again, it does not matter. Y equals 2x plus 3, and every time I see my x, I'm going to replace it with my value. Y equals 2 times my x answer plus 3. I'm just replacing that x with this x answer, and that's negative 2. And I get y is equal to negative 4 plus 3. Simplify some more. And I get y equals negative 2, and negative 1 is my solution. So here I have, sorry, I'm recording. So here I have my two equations again, and I noticed that, oh, sorry, I was distracted. Someone's at my door. So here is my answer, and I could do a quick mental check. Here's my x answer, and here's my y answer, and I could plug it into each one to see if it checks. Again, here I have y equals this x minus 5 and y equals this. Since they both are equal to y, I could simply just set them equal to each other. So I'm going to write x minus 5 equals 5x plus 11. And then now I'm going to solve for x. So I'm subtracting x from both sides. Hi, Roseanne. And I have negative 5 equals 4x plus 11. And now I'm going to solve for x by subtracting 11 from both sides. I get 4x is equal to negative 16. Divide by 4. And I get x is equal to negative 4. I'm not going to put a box around it yet because now I've solved for x. And again, I have two variables. I need my x answer and my y answer. So now I'm going to substitute my answer into my favorite equation. It doesn't matter which one I choose. And I'm going to choose the easy one because that makes sense to me. So I'm going to write the original equation, y equals x minus 5. And now I'm going to replace the x with my answer. And y is equal to negative 4 minus 5. Simplify that and I get negative 9. So my answer is, remember, if I were to graph these, they're two lines and I know they intersect, so I need my coordinate. Where do they intersect? Well, it intersects at negative 4, negative 9. So that's why we put our answer in a coordinate system. Now, what if in the case I do not have x, y equals, and y equals? Only one variable is isolated. So what happens when only one of them is isolated? So I'm going to take that one and I'm going to plug it into the x in the other equation. So I'm going to take one and plug it into the other. Let's see. So here I have 5. And do you see this x here? So my x is here, and all of this is going to be replaced in there. So I'm going to write it as 5, and then parentheses, and I'll leave space for all that, minus 2y is equal to 7. So I need an x, and I have a y, so I'm going to rewrite my second equation with nothing but y's, just like what we were doing with fair trades. I just need one variable. So I'm going to take this x answer, which is this, and I'm going to plug it into that x. So I have 3y minus 9. Now everything is in terms of y. Now I'm going to distribute, and I have 15y minus 45 minus 2y equals 7. Then combine like terms, and I get 12y minus 45 equals 7. And now I'm going to add 45 to both sides. And I get 12y is equal to 52. Oh, that doesn't go unevenly. Did I do something wrong? 15, here it is. This is 13. And now 52 divided by 13 gives me 4. So y equals 4. Make sure my signs are right. Now, I'm just like I did before, I'm going to pick my favorite equation. But to me, it makes sense to pick the first one because it says x, and I found y. I know y is now 4. I need to solve for x. Since it's already isolated, I'm going to choose the first one. Again, it doesn't matter, but I'm trying to pick something that makes the math the easiest. And every time I see y, I'm now substituting this answer here. Okay. And now I have my y answer. I get 12 minus 9, and I get 13. So x is equal to, 3. So x is equal to 3. And then I could do a quick mental check to see if these 2 points are a solution to these two equations. Okay, now let's look at this example. And again, in my sidebar, I kind of wrote down the steps. You plug one equation into the other to have only one variable. That is our goal when we're doing that substitution and solving for our systems. We're going to substitute an answer into our favorite equation and then solve again. Okay, so here I have y equals it's by itself. So I'm going to take this equation and I'm going to take that and plug it into that y, okay, since it's isolated already. So I'm going to write 4x plus 2 times that quantity equals 0. So I'm replacing everything in terms of x, meaning I want just x's in my equation. So that's what I'm doing. And I'm going to distribute. So I get 4x minus 12x minus 40 is equal to 0. Combine my like terms, and I get, and now I'm going to add 40 to both sides. And that goes away, and I get negative 8x equals 40. I'm going to divide by negative 8, and x is equal to negative 5. Now, I found my x answer. So now I'm going to need to find my y answer. Okay, I need to find this. So now I'm going to, where's my undo? No undo. Here it is. Now I'm going to substitute into my favorite equation again. Okay, again, it doesn't matter, but again, I'm going to pick ones where I could do my math easy. Since I need to solve for y, to me it makes sense to use the second equation. So every time I see an x, I'm going to replace it with my answer that I got. I don't know why it takes twice. There we go. And that's this here, that value there. So y equals negative 6 times my x value, which is negative 5, minus 20. And simplify, I got 30 minus 20, and y is equal to 10. So if I do a quick mental check, and I'm going to do that for this one here, 4 times my x is negative 5, plus 2 times my y answer is 10. Does that give me 0? And yes, that does. Negative 20 and 20 does. So that. And I'm going to check it's the second one. I have y, which is 10 minus equals negative 6 times my x answer, minus 20. And I have 30 minus 20. That gives me a 10. So yes, that checks. So I know for sure that is a correct answer. So what if there isn't a variable that isn't isolated? So I'm going to take one and isolate one of the variables to plug into the other. So I'm just going to isolate the x. So that means I'm going to subtract y from both sides. And now I have x is equal to 8 minus y. Hold on, I'm recording, Jovino. And this one is 4x plus 7y equals 50. Now I could take this and plug it in to here. Oh, you erased. Oh, there we go. So that's what I would do. So if there isn't one that's isolated, I'm going to pick one and isolate one of those variables.